Now let's talk about traces. The traces of a surface are the cross sections created when the surface intersects a plane parallel to one of the coordinate planes. Now the coordinate planes are the planes that are the XY plane that we see here, or it could be the XZ plane, or it could be the YZ plane. Those are the coordinate planes because they incorporate the axes, either the X or the Y or the Z, or the X or the Z. And with those coordinate planes, it says the traces of a surface are the cross sections created when the surface intersects the plane parallel to one of the coordinate planes. So in essence, those coordinate planes, actually the planes that are creating these traces, are going to be parallel to one of the three coordinate planes. Okay, so take a look at this first one here. We got y equals x squared right here. And that's just the graph. We've seen this one in the last video. So now I created the plane here, z equals 0. Now this plane right here intersects with this function here, and it creates this parabola. So that's the y equals x squared. Now it keeps going too, and we'll talk about that in a little bit. But when I look at the upper view, it's easier to see that, hey, this is a parabola here. So that's what we're doing. And when I'm looking at the picture of this here that you see in red now is all that I would see. Now this one we can actually graph it and look at it. It's very easy to see what it is. But some of the other ones, because I can't put these in my calculator, I can't graph them. So this here is a parabola, and here's my plane, the XY. So that's what it looked like, be my parabola. Terrible drawing, though. But anyways, that's the first one. Take a look at these next ones here. This is also the y equals x squared, and I put more planes that are parallel to the z equals 0 here. Oops. I got z equals 1 and z equals 2. And you can see what's going on here. Now, each of these are parabolas of the same size and same direction, same width. There's no change in that. So now if I just drew each of these traces, I would be able to see that if I kind of just completed it, it would be the shape that I see here. And that's really what's kind of nice about these traces, because I can do these traces with not, with just portions or little bits of information with these traces. I can get a really nice complete graph. Now look at these other traces here. This is another one here. And if you see this, that's the z and that's the y. So it's the zy. So that means I'm not going forwards or backwards. So that means x is 0. So x is 0 for this. Now notice what it creates when I have this x equals 0. It creates this line, that's it. So all I would see is this plane with the line in the middle. Straight down, it'd be a vertical line, at least from there, from that perspective. And then let's say I did x equals 1. That means I would come out 1. And all that would happen would be this line would move over a little. Okay, so it'd still be just the one plane with a line. So that's what those traces would look like if I drew them parallel to the x equals 0. Now let's look at these down here. So when I look at this one here, this one is the xz plane, and that means I'm not going left or right. So that means my y equals 0 here. And all I see here is a line, just like I did with the x equals 0. Now, when I move a little further on here, let's say I'm going a little further over now, one thing I'm going to see is the original one was a straight line, just one. And as I go further out from there in the right direction, the positive y direction, I'm going to get two lines. So each of those, as I go further out, are going to be lines that are further apart. That's really it. So that doesn't really help a lot either. I think the ones that help the most is this first one we did here, the planes that were parallel to the z equals 0. Okay, so now let's take a look at the next one here. So here's the third one here. This is z equals x squared over 9 plus y squared over 4. Now this is what we call a paraboloid. Now, if you look at this one, I just did a trace already here, and that looks like the YZ plane. And notice that means I'm not going forwards or backwards. So that tells me my x equals 0. And looking at this one, I get a parabola. Now remember the name, it's a paraboloid. So when I look at it with the x equals 0, I get a parabola. Now look at this one to the right here. When I look at this one here, this is a XZ plane. So that means I don't go left and I don't go right. So that means my y equals 0. And that also gives me a parabola. And that parabola looks wider than the other one. Now, if you guys know anything about these equations here, so for instance, let's say my x was 0, because that's what that means, right? That means I would take this and take it right out. And all I would have is z equals y squared over 4. Okay, now this is gonna rise a quarter here. And when I look at this one here, that means when I move over 1 and the y, it's going to go up a fourth. And then when I take off the next one here, which is, this one here, and I take that away, because my y was 0 now, I'm going to get x squared over 9. So if you look at that one's going to be, or take longer to actually curve upward. So therefore, that's why it's going to be wider here than it is with the others, with the x equals 0. So there's my equation there. So it seems it's going to be wider for that reason. Now take a look at the next one here. This one here is my z equals 0. Right here. So that one, if I graphed it, would only give me a dot in the middle there, because it hits just at that vertex there. Okay, but if I continue with these and I say, hey, let me put the z equals 1, z equals 2, and z equals 3 here. And what you'll see is you'll see these cross sections happening. But notice this, I got a little carried away there. That one's going to be bigger. This one will be smaller. And this one down here would even be smaller. So then if I put those together in a way like this, I would get that shape back. So that's the benefit to it. And you can see with this graph on the right here at the bottom that I wanted you to see how these look. Those are just ellipses, and that's what I'm getting for each of those. Now what's really cool about that is if I pick the z equals 1, for instance. So let's say I said z equals 1. If you know anything about ellipses, what you'll notice is this 9 is really 3 squared, and 4 is really 2 squared. And what that means is when it equals 1, that 3 there would be the distance that I am on the x. So let's say this purple one was z equals 1 here. Then that tells me from the center to that edge is 3. And then in the other direction, the y direction there would be 2. That's kind of how that works with ellipses. That is how it works with ellipses. So anyways, that's our ellipses and our paraboloid. So now let's take a look at this one here. This is what we call an ellipsoid. Now this ellipsoid is x squared plus y squared over 4 plus z squared over 9 equals 1. So this is what it looks like here, down here below here. That's an ellipse. And what I did for this first one here is the xy trace, or the yz trace, which tells me x equals 0. That's the plane we're dealing with here. So we get this nice ellipse here. Oops, terrible looking ellipse. So that's the shape I would get. I'd get that nice ellipse there. Now again, remember my x is 0 here. So it's like this piece goes away. And just like I talked about on the last shape, that means my y would be 2 away from the center. So this would be a 2. Whoops. This here would be a 2. And then my z would be a 3 because that's 9 squared. So that would be a 3 there. So we kind of see how we get that nice ellipse there. It's beautiful. All right, so let's take a look at the next one now. Now for this one, this is the xz plane, so my y would equal 0. So now let's take a look at this ellipse. Now with this ellipse from the center here, think about this one now. This means my y is 0, so this piece goes away. And I have x squared plus z squared over 9. So that x is going to be 1 away. And that z is going to be 3 away. So it gives me that ellipse. And now let's look at this third one down here at the bottom here. This one here gives us a nice ellipse. And this one would be z equals 0. And that tells me that, hey, the z piece would be gone. It'd be zeroed out. And then I would end up with my x being 1 away. And then my y being 2 away. So there'll be that ellipse there. So when I look at it all three ways here, and I notice I get an ellipse, elliptical shapes here, that's telling me that this is going to be an ellipsoid. That's how I know what shape it is, by just looking at the traces, just zeroing out one of these components. So in essence, I just take this here and just say, okay, this one's gone. Okay, that's an ellipse. So it's an ellipse that way. I take this middle one out. It's an ellipse that way, and I take the first one out, and that's an ellipse. So I know it's going to be an ellipsoid. That's how I look at these and am able to determine by the equation what they actually are. Now this one to the right here, I just kind of wanted to show you multi-levels of this. So this means I'm going to get an ellipse here, an ellipse here, and an ellipse here. But as I get to the top, those ellipses are going to get smaller. So then what I could do with all of those pictures collectively is I could create actually the ellipse by using those traces. And that's where the benefit of these traces comes in. Without having the technology to graph these, I could still come up with those ellipses that way. So for instance, I could say, hey, where my z is going to be 2 or my z is going to be 3. Now, I know the highest my z can go is 3 because I know this is that 9 below it is really 3 squared. So I know this is only going to come up 3 high. And that's where these come handy. And I know my x is only going to come out 1. And then my z is only going to come out 2. So I know when I go above that, I'm not going to get anything because I'm not even touching the graph anymore. So now let's recap all these. So when I look at this first one, here's my ellipsoid, and that's what we talked about previously. That's just x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. And that's what we see off to the right here. Now the one below this is a hyperboloid in one sheet. Now we didn't get into these, but we could do traces just the same. And if I did an xz trace, I would get this nice shape here. And that's a hyperbola if you look at that shape there. And that would be if I did an xz trace, that would give that hyperbola to me. In both ways, actually. Actually, the easier one to see, and for me to draw probably about the same difficulty, would have been the YZ. But that's about the same. Now this is where we get more hyperbolas of two sheets right down below here. So notice this, and this is the indicator that helps me out a lot with these, is with the one sheets, notice I only have one minus here. Okay, with the two sheets, I have two minuses. And that's how I kind of remember one sheet to two sheet. This one here, cone, is just a special one sheet in a sense that this is only one negative still just the same. So that's the elliptic cone is what they call that one. Now the one below this, the elliptic paraboloid, this is the one we've seen. They call it elliptic because when we look at it from the top or any trace that we do that are parallel to the z equals 0, we're going to get an ellipse. So that's why they call it an elliptic paraboloid. And when I look at it sideways, what do I get? I get parabolas. So that's why they call it an elliptic paraboloid. Now the last one here is a hyperbolic paraboloid, which this is interesting too because I look at it the one way, like the xz trace, I'm going to get a parabola. Or if I look at it the YZ trace, I get another parabola, an upside down parabola. Okay, those are two parabolas. And then when I do traces that are parallel to the z equals 0, which I'm cutting it this way, I'm going to get hyperbolas. So that's where it's a little more interesting there. That's called a hyperbolic paraboloid. So a lot of these names, when you hear them, kind of give you an idea of what you're dealing with when you get them. But notice this one here. This is a z equals x squared over a squared minus y squared over b squared. So I got a minus there. And then you look at the elliptic paraboloid. Those are both plus. So that's how I tell the difference with those. When I have a z equals 2 squareds I'm plussing, I'm adding together, that tells me that it's going to be an elliptic paraboloid. When I have a minus here, it's a hyperbolic paraboloid. So there's just a summary of most of the shapes that we've seen and then the rest that you haven't. So that's what we're going to be dealing with for the rest of this class.